All right, class. This is Mr. Eggleston, and this is lesson 4.7 for Algebra 2, Funky Froyo Part 2. I'm making this video because over the course of the 3 periods I had you guys, each of my presentations lacked a lot, and I was not very happy, and specifically my 6th period we won't even go into, it was horrible. So if you're my 6th period, I'm sorry you had to witness that. So this is about inverse functions, and this is my video on it. This is what I do for my Algebra 1 classes. I might start making my own videos for Algebra 2 so that you can see Mrs. Wilson's take and my take on these videos. And you can decide, which one you like better. You'll have 2 options. Who knows, that will probably benefit you. But here's the dealio. Remember back in our last lesson before Christmas, we were talking about the school jazz band is playing at Sweet Yo's, which is a really silly name for a yogurt shop. Okay, it costs $5 to get in the door of the event, and if you like to eat any yogurt, froyo, while you're listening, it's you can buy it for 40 cents per ounce. Okay. So in the last lesson, taking that information, we were able to write this linear expression or function equation, function definition. That is the $5 entrance fee plus 0.40, which represents 40 cents for every Z ounces. Okay, so this gives the total cost of attending the event if you order Z ounces of yogurt, of froyo. So the input, okay, what is the input of the function? Well, this is the input. It's the Z. It's inside the parentheses next to the function name, F. So the input is Z, which is the ounces of yogurt, so froyo. So what is the input of the function? It's Z, and that's the ounces of froyo. So here notice I labeled the bottom, the horizontal axis, and I labeled that as Z or Z, ounces of froyo, okay? Well, the output of the function is F. Remember, this is the output, whatever that is, all right? So this F is the output of the function, which is the total cost of buying froyo and attending the concert in dollars. Okay, and I put that along the vertical axis right here. So this is F of Z. Okay. Now, traditionally, the horizontal axis is the independent variable, the one that we call independent. It's the x, basically, in our old equations. And the vertical axis tends to be the dependent variable, or what we usually call y, the y-axis. So the x-axis, the horizontal axis, is whatever is inside the function, whatever variable, x, z, y, whatever it is. And the vertical axis is just what the function is, which is f of z. And technically, that's the total cost of your night out, all right? So now Sweet Yo's restricts the number of ounces you can get to 24. You can't get any more than 24 ounces. I guess they're afraid of running out of yogurt. So what's the minimum amount of money you need? And what's the maximum amount of money you might need? Well, the minimum amount of money will occur when you buy no yogurt, 0 ounces, which happens to be $5 or $5. The maximum amount of money you need would be the money needed to go to the concert, the 5, plus the money it costs to buy 24 ounces of yogurt, since that is the maximum amount you can get. So when you plug this into your calculator, you get $14.60. All right. Well, each of these turn into an ordered pair. 0, 5, and 24, 14.6. So these 2 points are the beginning and the end of this function, okay? So now they'll want us to graph it. Well, let's start at 0, 5, which happens right there. That's 0, 5. Okay. And then we have the point 24, 14.6, which is right there. Notice all I did was connect the two with a straight line because it's linear. You know it's linear because look at the original expression. That's an equation of a line. Okay. Now, what's the domain? Well, the domain is the beginning along the x to the ending point along the x. So that goes from 0 to 24. So the domain can be written as a compound inequality like this, or d is less than, the domain is the fact that z or z is greater than or equal to 0 and less than or equal to 24, written as a compound like this. All right. And the range is we begin at 5 and we go up to a max of 14.6. So we get 14, we have this compound inequality. Now, what I'm going to start showing you is that there's another notation, and it's a lot of times referred to as set notation, that you can write that inequality as that expression. Specifically, pay attention to the fact that it has 2 brackets, and it's an ordered pair, 0, 24. When you see this, the brackets mean or equal to, so it can equal the endpoint, which is what these say. And then it's just the 0 and the 24 written as an ordered pair. This is has the same exact meaning as that. Likewise, our range is our lowest value is 5, because that's if you buy nothing, you have to have 5. So that's the minimum value. Our maximum when we buy 24 ounces of froyo is $14.60. So you can write the compound inequality as this. 5 is less than or equal to F is less than or equal to 14.6. Now, just like before, we can rewrite that in shorthand as 5, 14.6 with brackets on either side. The brackets just mean it's or equal to. It would be parentheses if there was no or equal to, if these were open circles. But because these are closed circles, they're brackets. All right, that's the wrong graph. Since these are closed, they're brackets. Okay. And yes, there's a bunch of ambiguity because oftentimes when you write like this, it looks like an ordered pair, like a point, and it's not. It means something totally different. Okay. Now, number 2, we also wrote the inverse. This ugly expression is the inverse function. We did this in our last lesson. If you really look at this, this is a line. It has a weird-looking slope, 1 over 0.4, and then a weird-looking y-intercept, because that would be negative 5 over 0.4. So it looks weird. All right. Give me 10 minutes, kids. No, 20 minutes. I know, I'm doing a lesson. Then you go right ahead and you can come back. Sorry, I had some students coming in. All right, so it's a line. Now, here's the inverse function that you came up with last time. It's right here. All right. Notice the input now is dollars spent. Okay. And what is the input of the function? Well, the inverse, okay. And then what is the output? Well, since here the input's dollars, the output must be ounces of yogurt. Versus up here, the input was ounces of yogurt, and the output was dollars. Okay, so that's what it means to be the inverse. Remember, you switch input and output. So it's the amount of ounces of yogurt you can buy for D dollars is the output. It then says graph the function. Well, if you go back up here, notice in blue, I took each of these points of the original function, I just swapped them. So 0, 5 became 5, 0. 24, 14.6 became 14.6, 24. All right, all I do is switch X and Y. So that's the inverse. So you plot both those points, okay, to graph it, just like we did before. So 0, 5 turns into 5, 0 is right here. And then 24, 14.6 becomes 14.6, 24. And then we can just connect the dots. And that's our invert graph of our inverse. Now, okay, where are we? So notice the domain is from 5 to 14.6, and the range is from 0 to 24. Okay. And so it's right there. You could write that in set notation as bracket 5, 14.6, close bracket, and bracket 0, 24 for the domain and the range. You can write either way. Okay. Now, what do you notice about the graphs of the two equations? How are they related? Well, they are both linear. They are both lines. That didn't change. And the input of one becomes the output of the other. That's the main thing, is that you switched the input and output, or X and Y. All right. And then the final question is, if Ross spends $9.40 for the event, how much yogurt could he get? Is there any other amounts of yogurt you could have, he could have bought that would cost him $9.40 total? Explain. The answer to that is the following. Well, we just used the expression they gave us, which is D minus 5 over 0.4. We put in $9.40, which when you subtract 5 gives you $4.40 divided by 0.4, and that works out to be 11 ounces. So how many ounces of yogurt can you buy for the $9.40? 11 ounces. Are there any other amounts of yogurt you could buy with the same amount of money? And the answer is no. Okay. Oh wow, it's acting funky. You can only get $9.40. I'm sorry. $9.40. You can only get 11 ounces for $9.40. And I'm having issues. You can only get 11 ounces for $9.40. Okay? That's kind of a key thing, because since that's true, we say that f of x, the cost for a set number of ounces of yogurt, is invertible. Because of this, that for each input of the inverse, you only get one output. We say that f of x is invertible. Its inverse is a function. I don't know, I think it's I or ABLE. All right, the last little bit before we move on, I create another video for the check your understanding is the quick notes. From watching this, we see that learning target number 1 and 2, graphs of inverses, the graph of a function f and the graph of its inverse are reflections over y and x. Or, excuse me, y equals x. Okay, you learned that in geometry. Remember when you were doing transformations of functions or graphs, and when you switch x and y, you learned that was supposed to be a reflection across the line y equals x. Since that's switching x and y, what the graph became was its inverse, and so the inverse is symmetric across the line y equals x, or reflections across it. Okay. The domain of f equals the range of f inverse. The range of f equals the domain of f inverse. We switched x and y. Okay, that's what all of this comes down to. You switch x and y. Learning target number 3, a function is invertible, or this is kind of high-end technical language, 1 to 1, if its inverse is also a function, which means that each x goes to only one y, but each y is only connected to one x. Okay? And that leads us to what they call the horizontal line test. If you draw a horizontal line and it only touches the graph at one point, then its inverse of the function, I can't even say it. Since that's the graph of a function f, its inverse is also a function. In this case, it's not a function. As you can see, you draw a horizontal line and it touches the graph, in this case, 1, 2, 3 locations. So its inverse is not a function, even though it is a function. When you find its inverse, it's not going to be a function. Okay? So, last little bit before anything else here. Okay? Here's an example of finding the inverse of a function. If you were given the function f of x equals 2 times the square root of x minus 3 plus 5, that's the function. I want you to find the domain and range of the function, and then find the inverse and find the domain and range of the inverse. Well, the original function, which is in yellow, it's a square root function, which you should know looks kind of like what this shows up here. Right? It has a starting point and it moves to the right. Its domain knows that it has a starting point and then it only goes to the right. So the domain, it's going to be finding the starting point, which is what makes the inside of the square root equal to 0. Or you can look at this and say, hey, that's a square root function shifted to the right 3 units. So its domain is going to be x is greater than or equal to 3. Pretty easy. Or 0, comma, infinity. It's not 0. Sorry, it's not 0, it's 3. And then parentheses. Now you're wondering, Mr. Eagleson, am I going to require you to know this set notation? No, I'm just going to start to show it to you to get you used to it. I'll be looking for something like this. All right. Now, the range, you should know, starts at the beginning point and only goes up. So the lowest point on this graph is the 5. So the range is y is greater than or equal to 5, which would be 5, comma, infinity, parentheses. Okay? Now, how do you find the inverse? First, change f of x to y, just so you don't get confused. Simple change. Now, second, switch x and y. So that would be x now equals 2 square root of y minus 3 plus 5. I just switched x and y. Third, solve for y. So how would I solve for y on this? Well, I need to isolate the square root because that contains the y. So to isolate the square root, I'm going to drop opposites and subtract 5. I'm going to denude the outside. So now we got x minus 5 equals 2 times the square root of y minus 3. Now I have to strip off the 2 on the outside. So since it's multiplying with the square root, I'm going to divide. Since we're multiplying the square root by 2, we're going to divide both sides by 2. All right, and now we got x minus 5 over 2 equals the square root of y minus 3. Now, the inverse, or to undo a square root, is you have to square it, right? Because the square root of 4 is 2. And if I squared both sides, 2 squared is 4. And when you square the so this is going to be 4 also. So the square root disappears. It's the inverse operation. The inverse of a square root is a square, just like the inverse of a square is a square root. So that means I'm going to square both sides. And now, over here on the left, I got x minus 5 over 2 squared equals y minus 3. Finally, add the 3, and we have y equals x minus 5 over 2 quantity squared. I'm just going to be lazy about it. Okay. Plus, because we're going to drop opposites, right? Plus 3 on the outside. And this is the inverse function. So the last step will be change this y into the function notation for the inverse, which is f to the negative 1. The f inverse of x equals x minus 5 over 2 squared plus 3. This is the inverse of the original square root function. Okay? Yes, lots of steps. Okay. First step is to change f of x to be y, which is where I started right here. Then switch x and y, which is here. Go through all these steps to solve for y right here. And the last step is to change that y notation back into function notation, where instead of f of x, it's now f to the negative 1, f inverse. Okay. Notice that by doing this, what we've said is now we would say the domain of this is going to be the range of the original. So it'll be x is greater than or equal to 5. And the range, it's going to be the domain, and that's going to be y is greater than or equal to 3. Okay? All I did was switch the domain and range from the original. This just switched. Okay. And you might say, Mr. Eggleston, this expression for the inverse actually is a quadratic. X can be all real numbers. You're right. But the function we started with could not be all real numbers. And that impacted what the domain and range was going to be of your inverse. Because you're doing a square root here, that precludes any x value that makes the inside of the square root negative. So all x has to be greater than or equal to 3. And since we switched x and y, the domain became the range. So the range was y is greater than or equal to 3, and the domain is x is greater than or equal to 5. Okay? And that's how you find the inverse. That's it on the notes aspect. I'll do the check your understanding next.